Hey everyone, so this next video is on actually the next two sections because they're both pretty easy, so we always just do them together to get a little bit ahead. So I'm just going to go through the theorems for both sections and show you an example for each one like I always do. So here's the first one. It's 7.4. 7.4 is on parallel lines and proportional parts, so it deals a lot with when parallel lines are cut by transversals or when you have parallel lines inside of a triangle, the different things that happen. So this first one is the triangle proportionality theorem, and it says if a line is parallel to one side of a triangle and intersects the other two sides in two distinct points, then it separates these sides into segments of proportional lengths. So what that means is, in this picture here, in example 1, see how we have this triangle ABC, and we have EF that's parallel to a side of the triangle. So what this theorem is saying is that where EF intersects the sides of the triangle, AC and AB, it cuts it into 4 segments that are proportional. So there's 1, 2, 3, 4. So we learned in the previous section or sections at some point, I don't really know. We learned at some point that something like this, you can add together the sides and you would do like bottom of the small triangle to bottom of the big triangle, top of the small triangle to top of the big triangle, and you'd have to add some pieces together. Well, not anymore. This theorem allows us to use these 4 segments, 1, 2, 3, 4, and you can use them in a proportion. There are 4 spots in a proportion, 4 segments. So when you do it, there are lots of ways to set it up. I could start with x plus 22, so I could go like bottom to bottom, and then you'd want to use the one that's across from the x plus 22, 18 to 6. You could go bottom to top, bottom to top. You could go this part first, like x plus 2 to 6, x plus 22 to 18. There's a lot of different ways you can set it up. So I'm just going to go with x plus 22 to 18 equals x plus 2 to 6. And like I said, there's tons of ways you can set it up. This is just one of them. So then you cross multiply. When you cross multiply, don't forget to distribute. So I'm going to finish it over here since I'm not going to have enough room. So it's going to be 6x, and then 6 times 22 is 132. And then we're going to have 18x plus 36. So we're going to subtract 6x, subtract 36. So then we're going to have 96 equals 12x divided by 12, x is 8. So there's the first one, triangle proportionality theorem. Next is mid-segment theorem. So mid-segment is a new vocab word. And so a segment whose endpoints are the midpoints of two sides of a triangle. That's what a mid-segment is. So this first part, a segment whose endpoints are the midpoints of two sides of a triangle, that's called a mid-segment. A mid-segment is parallel to the third side of the triangle, and its length is 1/2 the length of the third side. So if we look at this picture here, CD is a mid-segment. I know that because C and D are the midpoints of these sides. And I know that because of the markings. Remember, midpoint makes 2 equal segments. So let's just get that out of the way, saying that CD is a mid-segment, because sometimes you might just be told that something is a mid-segment, and then you'll have to mark the congruent pieces. Other times you may, it'll be a situation like this where you're concluding that it's a mid-segment. So CD is parallel to AB. And then also it says BD is y plus 8, so y plus 8. And DE is 5y minus 8. And then AB is x plus 12. CD is 5x minus 3. So we're going to solve for x and y separately here. Obviously, these two are just equal. That's pretty straightforward. Y plus 8 equals 5y minus 8. So that's going to be 16 equals 4y. Y is 4. Okay. And now for x, we just learned that this side that's parallel to the third side of the triangle, the mid segment, is parallel to this side. And it's also 1/2 the length of this side. So 2 of these is equal to 1 of these. So you could do 2 times 5x minus 3 equals x plus 12. So that's going to be 10x minus 6 equals x plus 12. So that's going to be 9x equals 18. So x is 2. So again, the mid segment is half of this side that it's parallel to. That's the mid segment theorem. I'm going to erase some of this so it's not a total mess. So what was this? We had... Okay, anyway, moving on. So then we have a corollary. A corollary is just something that basically like stems from a theorem. And so a corollary, this corollary says that if 3 or more parallel lines intersect 2 transversals, forgot how to spell for a second there. 2 transversals, that just sounded out. Then they cut the transversals proportionally. Okay, so in this example we have, I mean, this isn't actually a real example. I'm just going to talk about different ways you could set this up. So here are 3 parallel lines. Here are 2 transversals. So it basically just means that it creates these 1, 2, 3, 4 segments that are proportional. So you could go like this to this equals this to this. There's lots of different ways. You can also use like this whole segment and this whole segment. So I'm just going to list out some possible proportions that you can use. I didn't do a numeric, like an example with numbers or algebra, because I just wanted you to know that there's so many ways you can set it up. So possible proportions, I'm just going to list out a couple. Usually I have you guys tell me, but you're at home, so can't do that. All right, so you could do like AB to BC equals DE to EF. That's a pretty basic one. You could do AC to AB equals DF to DE. You could do, let's go across. You could do like BC to EF equals AC to DF. Whoops, not OF, DF. So I did like this to this equals this to this. So I'm going to put like etc. There's a lot more. We're not going to list all of them. I just wanted to show you a few different ways you can set it up. So when you have a situation like this, there's lots of ways you can set it up. That's the point of this. Okay, one more corollary for 7.4. And it says if 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. And so what it means to cut off congruent segments, what it means, oh my gosh, I spelled it wrong again. What is wrong with me? It's very late. Okay, that's why. Transversal, there we go. Okay, so what it means to cut off congruent segments is you see the parallel lines, obviously. You see the transversals. Whoa. And then see how like these 2 are congruent here. If these 2 are congruent, then that means these 2 are congruent. So we can mark those as congruent as well. That's all it means. So notice that this one has an X and this one has a Y, but these 2 have Y. So I'm going to set these 2 equal to each other. So I'm going to have 3Y, just kidding, 2Y plus 2 equals 3y. Oh, that's why I was wrong, 3y. So now if I subtract 2y from both sides, I get y equals 2. Then I can take y equals 2, plug it in here, and use that to help me find x. So let's do that. Y is 2, so that's going to be 2 times 2 plus 4. 2 times 2 is 4 plus 4 is 8. So this is 8. So this is 8. So now I'm just going to do 3x minus 1 equals 8. So 3x equals 9. X is 3. So if you have parallel lines cut by transversals and you have congruent segments on one transversal, you have congruent segments on the other transversal as well. So that's it for 7.4. 7.5, we've actually already used some pieces of 7.5 without you even knowing it. And I realized it after I assigned it, and you guys all figured it out. So this is very easy. So when you have special segments in similar triangles, they're basically proportional to the sides. So what this says is when two triangles are similar, corresponding medians, angle bisectors, and altitudes. I can't spell that. Altitudes. There we go. Are proportional to the corresponding sides. Okay, so if you have similar triangles, medians, angle bisectors, and altitudes are proportional to the sides. So basically, you would probably be able to figure this example out on your own. But if I had these two triangles are similar by angle, I have these altitudes that are outside the triangle, x to 7 would be equal to 10 to 8. So 8x equals 70. So it's 8.75. Okay. So the last theorem that we're going to talk about is the triangle angle bisector theorem. And this deals with just one triangle that has an angle bisector in it. So an angle bisector in a triangle separates the opposite side, so basically the side opposite the angle that's being bisected, into two segments that have the same ratio as the other two sides. So basically it cuts it into proportional pieces. And so what we mean by that is there are 4 segments here that we can use in a proportion. We have this left side of the triangle and then the bottom left side of that segment. And then we have the right side of the triangle and the bottom right side of that segment. So those are your 1, 2, 3, 4 segments here that are proportional. So for this one, I could do, well, first I need to figure out this one. So I can do 160 minus 100, which is 60. So I could do like R to 60 equals 110 to 100. You could also do like R to 110 equals 60 to 100. You could not do R to 100 equals 110 over 60. You can't crisscross, just like with other proportions as well. So if I were to cross multiply here, I'm going to have 100R equals 6600. Divide by 100. And I get R equals 66. And so that's it. So 7.5 is pretty simple. That's why we kind of like lump it with 7.4 because you definitely don't need a full day on it. So that's that. That's the last theorem. And you're going to do some practice on both of them today. And that's it. Just let me know if you have any questions. All right. Have a great day.